In the previous video, we spoke about version control system, and then we discussed about different kinds of version control system, like local version control system, centralized version control system, and distributed version control system. We have already seen major differences between centralized and the distributed version control systems. Here we'll talk more about the differences by taking a working example. And once we are done with it, we will talk about a little introduction about a Git, which is a popular distributed version control system. Post that, we will install Git on our machine and see the version of the Git that is installed. Yeah, let's start with the differences between these two. So as we have discussed in the last video, in a centralized version control system, when you pull the code, you can see only the latest contents of the file. When I say latest contents of the file, let's say a file is created a week ago and I have been making changes to that file, or be it me or my fellow developer, we have been making changes to the file, and today file has some content. Okay, now in centralized version control system, if I pull a repository to my local machine, I'll have only the contents that are present now. I can't view the changes that were made to the file. I don't have any history. It's just that it pulls the latest copy. But in the distributed version control system, what happens is it pulls the complete thing along with the current changes. It will pull because, as you know, a version control system uses the database. In distributed version control system, what we see is we pull the complete thing. Like so, when you pull the complete thing, you'll get the history of changes as well. So even though if you lose the server, this centralized server, what we can, even if you lose this one, we can use any of our local repositories and recreate it. So that is the advantage of this. We have discussed this already. Yet to discuss more about it, let's take an example, a software project. Okay, so now I'm working on a software project. What I'll do, I'll pull the files to my local machine, and then I started working on a file one. So I'm working on file one. I made a few changes to the code, and then I have to save it. So how to save that? What here, if you see in this diagram, to save anything, I have to connect to the server and then commit the changes. So for to save the changes, what I am doing every time is every time I have to connect to the server and then I have to commit it. So like, let's say if the server is down or if the multiple people are accessing it, you like the request might be slow, or even if the server is down, you have to wait till the server comes up, right? But if you see the distributed version control system as shown here, since the complete repository is pushed, what you can do is you can commit changes to your local repository. You will have the files here, right? So let's say I'm working on file 1. Whenever I make changes, I can commit to my local repository, because complete changes, database changes are also pulled into local machine, right? So what I can do is, let's say I make a change to a file 1. What I'll do is I'll commit to my local repository, and after some time what I feel is might be, file 2 also has to be changed. What I can do is I can make changes to the file 2, I can commit it. So once I feel everything is committed and everything is working fine, then only I can push to the server repository. Okay, so once I feel everything is working fine, I can push to the server. When you push to the server, so here you have made two commits, right? So all the commits that were committed to the local repository were pushed to the centralized server repository, like server as well. But here in the centralized version, what happens is, whenever you make changes and want to commit it, you have to connect to the central server and then you have to commit the changes. But here it's not the case. You can, whenever you feel that the changes are ready, you can commit it, and later on, once you feel everything is perfect, then only you can push it. So one more advantage what you can see here is, let's say I don't have internet connectivity. Okay, I'm working from train or bus, I don't have the proper internet connectivity. In centralized version system, what you have to do, you can't work. If it is a centralized version control system, you can't work because you cannot connect to the server, and you cannot push or you cannot commit your changes. But in distributed version control system, what you can do, you can like completely you can work on your project, you can commit changes to your local repository, because internet connectivity is not used to commit changes to the local repository. Okay, once you reach home, once you get internet, what you can do is, whatever changes that were committed to your repository, those you can push it. So this way, even if there is no internet connection, or even if there is some problem with the server, you can work it. But in centralized, you don't have that facility. So this is the advantage of DCVS over the centralized version control system. Okay, now we'll talk about Git. The introduction of the Git. Git is a popular distributed version control system. And why you say Git is so popular? There can be other distributed version control systems also, right? So Git, what makes Git stands among the other version control system is the way it looks at the data. So the way Git looks at the data is the differentiating factor between other version control system. Let's talk about that. So now if you see other version control systems, this is the way how other version control system works. So now it like let's take a file A here. Okay, now I have made changes to file A. In a traditional or a normal version control system, what it does is, see, this is a version 1, because initially you have a file A, you have file B, and then you have file C. Now when I make few changes to the file A, what a general version control system is, it will save the delta changes, which means it will capture only the changes that were made. It will not capture the complete contents. Okay, now my file would have 100 lines of code. I have changed only 2 lines of code in this, so my delta will have only information of those 2 lines of code. Now even file C also, it will capture the delta one. Now a developer comes and he asks the version 2 what were the file contents when in version 2. What it does is, it will compare these delta changes with file A, and then it will give you a file with the changed contents, like with the latest contents. Even the file C also, what it does is, it will compare the delta changes that were captured, it will compare with the file C, and then it will generate a file with these changes. Now even when I'm version 4, what it does is, now when I'm at version 4, 2 changes were made to file A, right? Delta 1 and delta 2. And what it does is, it will look at delta 1, delta 2 on the file A, and using these three, it will it will give you a file having the differences or having the changes delta 1 and delta 2. So if you whenever you request a file, what it has to do, it has to calculate these things, and then it has to give you a file. But the way how Git works is, now this is the diagram how Git looks at its data. Okay, initially you have a file A. Now what I have done is, I have made changes to file A. So what Git does is, it takes the snapshot, so which means it will have the all contents including. Now like I have 100 lines of code in file here, right? I have changed 2 more lines. I have changed 2 lines of the code in the file here. So what version 2 file will have is, it will have the complete contents, not the delta changes what I have shown in the above diagram. So basically what Git does is, it will take the complete picture of the file A and store it in the version 2 with the changes. So if there is any change that happens to a file, it will not store the delta changes. It will completely, create a new file, and then it will store that file in the new version. Now if you see, even the C file is changed. What it has done, it is not referring to the file C. What it is doing is, it has created a new file with the changes that were made by the developer. So if a person comes and asks for the version 2 files, what it does is, it will give you the new file. It need not, calculate how you have done in the first diagram. Now file B is not changed. If a file is not changed, then you need not, kind of create a new file. What a Git does is, it will just point to the file B. It will just refer to the file B, because nothing is changed. So this way what Git does is, it will look the data as a snapshot, not the differences. Even in the version 3, file A was not changed. So what it does is, it will refer to this file, because this is the latest file. File B is not changed. So this will refer to this, and this will refer to this. File C is changed. So it will create a new file. So likewise in the version 4, if you see, file A is changed. So this is my new file. And file B is changed. This is my new file. And file C is not changed. It will refer to this. So let's say a person comes and asks for the version 4 files. What it does is, it will give you A2, it will give you B1, and it will check for C2. Okay, C2 is referring to this one. It will take this file and give. So what it does, it just takes the files and gives you. It is not calculating anything. This is, so it looks the data as a snapshot. Like it will take the complete file. When you make a change, it will not just remember the changes. It will consider your complete picture, like complete state, as a snapshot, not like a differences here. That is this, because of the way it looks, it makes Git, the popular version control system. And let's see, this is the version, Git version control system working. So here you have a working directory, you have a staging area, and you have a repository. Okay. Now in my local machine, I'll pull changes from the repository, right? So you call that as a working directory. Now what happens is, in that you have a repository, and the repository name is some X. When you pull changes to my local, like how I have shown in the above diagram, when you pull changes, what happens is, you will have a folder created on your local machine named X. Okay, that is called as a working directory. Okay, now whenever I make a changes, what happens is, first you have to move changes to the staging area, and from the staging area you have to commit the changes directly. You cannot commit it, because that's a, kind of a precaution also. Whenever you whenever you click on, or whenever you close a file, what happens, it asks whether you have saved it or not. It's just kind of like, you can treat that way. So whenever you make changes to a file directly, you cannot commit it. Those files won't get committed. Those files has to move to the staging area. From staging area you have to commit it. So basically there are three stages involved. One is a working directory, where all your files are stored, and whenever a change is made, because if you don't stage the changes, now there is a file 1 and file 2. Okay, now now I made changes to the file 1, I made changes to the file 2. When I ask Git to commit, it don't know, because Git takes changes only from the staging area. It don't know what to commit, because I made changes to file 1 and 2, but I have not moved them to staging area. So what Git says is, there are no changes that are in staging area. How can I even commit them? So that is the, error Git will show. We will, you can discuss about these things more while you are working on a project. Like in the coming videos, we'll take a project and we will stage the changes, and then we will commit it. So you'll get more understanding. You need not worry at this point of time. So you can just see this diagram and then understand the staging area part. Whenever you check out a project, or basically whenever you pull the changes, what happens is you are pulling changes to your repository. Whenever you are making a change, you are moving it to the staging area, and from staging area it is getting committed. Okay, now let's install Git on my machine. First, before installing, let's see whether Git is there on my machine or not. I am using a 64-bit Windows machine. So the command to know whether Git is installed or not, or what kind of version is installed on our machine, is Git version. So it says the term Git is not recognized, which means that Git is not installed. So I'll go to the official website of Git and I'll install it. So I'll go to the official website of the Git, and then since mine is a 34-bit, I'm downloading a 64-bit installer. Yeah, I have downloaded 64-bit installer and I'm installing it on my machine. Yeah, it seems I have already done that before. That's why it has shown that. If you are doing it for the first time, it will not show that prompt. Yeah, we'll talk about Git Credential Manager while we are working on a sample repository. Yeah, it's getting installed. I don't want to view release notes now. Yeah, this is done, right? Now let's check the version. I'll type the same command which was used before installation. Now it did not give me the error. It showed me the version that was installed, like 2.43.0. Yeah. In the coming videos, we'll work on a sample project and we will use a Git to make changes, to pull and push changes, commit, and we will talk about the famous commands of the Git which people use in day to day life. Thank you.